I didn't recognize you because we met one time. No, I'm very high maintenance.
That's okay. I'm used to it. You deserve it. You deserve it. But I'm sorry. You just thought you said a clean slate.
I said you're going to have to deal with me eventually. Because that is a friend of mine.
Right. Right. So listen. So you let it go. Good. Not because someone needs to speak to that.
Okay. Okay, everyone, if you could take a moment just to mute your phone. You don't have to turn off your phone because you may want to live tweet us a question with hashtag functional forum. We'll be taking questions at the end with all the panelists. So if you can mute your phone, and also the door after we start will be locked, so there'll be no going to the bathroom. You're just going to have to hold it. We're going to have to use your kombucha glass to take care of it.
Picture warm, gooey cookies, crunchy candies, velvety cakes, waffle cones piled high with ice cream. Is your mouth watering? Are you craving dessert? Why? What happens in the brain that makes sugary foods so hard to resist? Sugar is a general term used to describe a class of molecules called carbohydrates, and it's found in a wide variety of food and drink. Just check the labels on sweet products you buy. Glucose, fructose, sucrose, maltose, lactose, dextrose, and starch are all forms of sugar. So are high fructose corn syrup, fruit juice, raw sugar, and honey. And sugar isn't just in candies and desserts. It's also added to tomato sauce, yogurt, dried fruit, flavored waters, or granola bars. Since sugar is everywhere, it's important to understand how it affects the brain. What happens when sugar hits your tongue? And does eating a little bit of sugar make you crave more? You take a bite of cereal. The sugars it contains activate the sweet taste receptors, part of the taste buds on the tongue. These receptors send a signal up to the brainstem, and from there it forks off into many areas of the forebrain, one of which is the cerebral cortex. Different sections of the cerebral cortex process different tastes: bitter, salty, umami, and in our case, sweet. From here, the signal activates the brain's reward system. This reward system is a series of electrical and chemical pathways across several different regions of the brain. It's a complicated network, but it helps answer a single subconscious question. Should I do that again? That warm, fuzzy feeling you get when you taste grandma's chocolate cake? That's your reward system saying, yes. And it's not just activated by food. Socializing, sexual behavior, and drugs are just a few examples of things and experiences that also activate the reward system. But overactivating this reward system kickstarts a series of unfortunate events: loss of control, craving, and increased tolerance to sugar. Let's get back to our bite of cereal. It travels down into your stomach and eventually into your gut. And guess what? There are sugar receptors here too. They're not taste buds, but they do send signals telling your brain that you're full, or that your body should produce more insulin to deal with the extra sugar you're eating. The major currency of our reward system is dopamine, an important chemical or neurotransmitter. There are many dopamine receptors in the forebrain, but they're not evenly distributed. Certain areas contain dense clusters of receptors, and these dopamine hotspots are a part of our reward system. Drugs like alcohol, nicotine, or heroin send dopamine into overdrive, leading some people to constantly seek that high. In other words, to be addicted. Sugar also causes dopamine to be released, though not as violently as drugs. And sugar is rare among dopamine-inducing foods. Broccoli, for example, has no effect, which probably explains why it's so hard to get kids to eat their veggies. Speaking of healthy foods, let's say you're hungry and decide to eat a balanced meal. You do, and dopamine levels spike in the reward system hotspots. But if you eat that same dish many days in a row, dopamine levels will spike less and less, eventually leveling out. That's because when it comes to food, the brain evolved to pay special attention to new or different tastes. Why? 2 reasons. First, to detect food that's gone bad. And second, because the more variety we have in our diet, the more likely we are to get all the nutrients we need. To keep that variety up, we need to be able to recognize a new food, and more importantly, we need to want to keep eating new foods. And that's why the dopamine levels off when a food becomes boring. Now back to that meal. What happens if in place of the healthy, balanced dish, you eat sugar-rich food instead? If you rarely eat sugar, or don't eat much at a time, the effect is similar to that of the balanced meal. But if you eat too much, the dopamine response does not level out. In other words, eating lots of sugar will continue to feel rewarding. In this way, sugar behaves a little bit like a drug. It's one reason people seem to be hooked on sugary foods. So think back to all those different kinds of sugar. Each one is unique, but every time any sugar is consumed, it kickstarts a domino effect in the brain that sparks a rewarding feeling. Too much too often, and things can go into overdrive. So yes, overconsumption of sugar can have addictive effects on the brain. But a wedge of cake once in a while won't hurt you.
Hello and welcome to the Functional Forum. What do you think? Best venue so far? And there's a lot of people that have been here a few times. Yeah, super excited for tonight. Got an epic lineup. We finally got a situation where we can do the kind of fun things we want to do with video. The very first Functional Forum, what we said is that we were going to show videos that you could curate for your patients. And I think that any of you who are interested in brain health, you can see videos like that Ted are making are really useful and exciting. So great to have you guys all in here today. There are some legends of the field of health and neurology right here. We got Mr. Kale himself, Drew Ramsey. You getting a dopamine response from that Kale? He gets that. Dr. Richard Isaacson. You're going to see him later. He's doing some the first preventative Alzheimer's for preventative work with Alzheimer's. We got Max. Welcome, Max. Dr. J. Lombard. It's a whole crew. Hey, so look, this is the most important topic, and so glad you could be here. But the reason I just wanted to mention before we start, there's a few people that have made this possible. Genomind, who is sponsoring today. Dr. J. Lombard is the medical director, and really excited to have them on board. N1 Health, we're going through a bit fast. N1 Health for doctors who want to do a concierge conversion into functional medicine. They're investing in practice actively, and we thank them a lot for their support of the Functional Forum ongoing. Just this last weekend, I was in San Antonio, Texas, and we went to go to this Freedom Practice coaching seminar. And part of our vision here at the Functional Forum is to empower functional and holistic doctors to be the next brand of entrepreneurs to be able to change healthcare from within, grassroots, and I think they're going to have a big role to play. You'll hear a lot more about that at the end and next month. Sakara Life, who enjoyed their kale salads. Let's have a shout out for Sakara Life. And also Healthy Habitats, who are one of our great sponsors, and they are here making the food. So we're going to talk about the evolution of brain health, and it has been just a flood of awesome new science that's been coming out recently. And so I just wanted to go through and show you some of the cool stuff that's been happening. So this was coming up. I don't know if you saw this, but there was this thing on WebMD which said there was an ad on WebMD. And if you participated in that ad as well, if you clicked on it to do a brief questionnaire, every possible permutation of things that you could put into that ad told you that you had a psychiatric disorder. Right? So to me, it's good marketing, but there's a lot of brief depression questionnaires that are going on in primary care that are sending people into the psychiatric medical system, and I think this is an interesting study just to see like how this kind of care is being delivered. The next thing I want to look at is looking at some of the science that's showing, what is the majority of things that we're using for psychiatric conditions, these antidepressants that rapidly altering brain architecture, and we're going to talk a little bit more about that later. This is pretty fresh, actually. I think this is just 2 days old. Pesticides used by farmers linked to high rates of depression and suicide. We're going to talk a little bit about that later, environmental factors, and that's certainly a big concern. And so, now we're looking at what are we actually going to do about it, and some of the most exciting things, and who's here is excited about the Brain and Gut Journal, first clinical journal. Well, I know why you're not that excited, because it's not coming out to 2016 now, so you have to wait a bit for that. So we just basically got all the best people on the Evolution of Medicine Summit, which was last month, and we had, Dr. Perlmutter, Dr. Ari Voljani, who were two of the editors, and also Leo Gallen's got some stuff in there. So we just finished that, and there's a lot of great stuff in there. You'll have to wait a little bit further for Brain and Gut. But now we're also even talking about acute issues like multiple sclerosis, looking at the intestinal barrier damage in multiple sclerosis. If you're a functional medicine doctor, you've known this for a long time, but more and more stuff is coming out. Neurogastroenterology, gastrointestinal dysfunctions, looking at acute brain injury, not just chronic brain issues. So this is interesting stuff that's coming out. Obviously, there's a whole lot of stuff between the microbiome and the brain, and so there's been a lot of good research coming out almost every day about the microbiome, and particularly with this type of issue as well. And so, this was just the other day. So this is Friday, October 3rd, so it doesn't get much fresher than this. University of Maryland School of Medicine essentially have identified a new pathway linking the brain to high blood pressure. So when we're talking about the brain today, we're not just talking about, we're going to talk about potentially Alzheimer's as type 3 diabetes. We're going to talk about the metabolic connections of the brain. But you can see that this is really interesting. There's no conclusions from this yet, but at least we're finding out more about it. So, if you're going to do one thing for your patients, obviously you want to go turmeric. Is there anything that this spice can't do? It tastes delicious. If you're a big fan of Drew Ramsey and you love a kale chip, you might as well have the curry flavor, because that's got it all in there. It's sort of yellow on the outside. Looks a bit weird, but it is delicious. And then this is the big news. Memory loss associated with Alzheimer's reversed for the first time. It's a small trial from UCLA, but it's really exciting to see this being reversed. And so we're going to talk a lot more about that. So, two of the people that you're going to see tonight are actually featured in this article that was in the Wall Street Journal. And this is basically Alzheimer's prevention for 30-somethings with no symptoms, and that's what we're going to get into tonight. You can see the acute importance of getting this right now. And so, we're going to get on with the show here. So,
this is a story of the world's next great epidemic and what can be done to stop it. My name is Max Lugavere, a filmmaker and science fanatic. I'm continually inspired by man's ceaseless ability to overcome his limitations. Bestowed with the human brain, the most complex object in the universe, each packed with 100 billion neurons, we build cities, fly in airplanes, and put robots on distant planets. We fight disease, we create art, we imagine realities that have never existed and bring them into being. Today there are 5 million people living in the US with Alzheimer's disease, a degenerative condition that robs us of the very essence of our humanity. By 2050, this number is expected to triple. But for me, it's personal. Okay, let's do a really small cognitive test. This is my mom.
What are you doing now?
Where are you right now?
In our rental apartment.
No, be serious.
I am.
It's 2014. We're not helpless anymore. Breadhead will uncover cutting-edge science that we're hungry for, to help us take back the fate of our defining characteristic, our minds. We'll undo decades of dietary advice that may be responsible for this epidemic.
We know that whole grains are a key player in healthy eating.
6 to 11 servings per day is what we need, just like the gasoline for the human body.
And test radical new thinking.
A group at Brown University coined the term type 3 diabetes to indicate Alzheimer's disease, the type of diabetes of the brain.
Even though you may not know it, your brain is under attack from wheat, carbs, and sugar.
Your brain needs more nutrition than the American Heart Association diet, the American Diabetes Association diet, and the USDA Food Pyramid diet.
a documentary to empower and give hope in an otherwise hopeless scenario. The fate of our minds lies in decisions we make at the checkout counter.
So, ladies and gentlemen, are you excited for that? I have the producer-director here. He is a star of current TV, and he is now engaged in this topic. Ladies and gentlemen, Max Lugavere. All right, Green Day fans out there, This is Brain Stew. So, Max, tell me about getting Hollywood interested in science.
Yeah, so a little bit of background on my work. I started as one of the main anchors of Al Gore's TV network, Current. And my role there was pretty much to get young people excited about the way in which technology was democratizing the tools of storytelling. And that sort of, it was amazing because at the time, Current was very ahead of its, ahead of the curve. YouTube had yet to really become ubiquitous at that point. But a sort of underlying thread from my time at Current and even before that when I was in college was always the way technology was impacting health and the way we were sort of at this the cusp of a radical tsunami of possibility as far as like health was going. And I kind of saw that. That's one of the reasons why I didn't go into medicine when I was in college. I ended up becoming a storyteller. And I found over the years that science was definitely siloed off to the more academic communities, but that has definitely changed. I think today people are more interested in science and health and things like that than ever before. In fact, a study that I love that was done in-house at the New York Times found that the most shared articles from the New York Times were those that inspired awe. And they were like, well, what is awe? It's kind of a nebulous concept. Well, it's usually things about science and about the ways in which technology pertains to sort of our health and our everyday lives. And so that's like the media side of things. But then I've always really sort of intuited this idea that food is information. I've always been a massive junkie for health and wellness, and it's sort of I'm very much of Ray Kurzweil's school of thought that biology can be reprogrammed. Like, I'm a big fan of The Singularity, but my favorite book of his is Fantastic Voyage, which is about the way you can eat so that you can make it to the singularity. And so the genesis of this project came when, to use a popular term, shit became real for me when my mom started having these sorts of kinds of cognitive difficulty, and so I felt at once upset by the whole thing, but very empowered too, because I feel like I was at this unique intersection where I could sort of see everything from 30,000 feet, and that's sort of the genesis of the journey for me.
So you've started filming already. Who are some of the guys that you put on film already?
Yeah, so we started up in Boston, where we were shooting with Dr. Alessio Fasano, who is sort of the gluten guy. He's the founder of the Center for Celiac Research. Brilliant, brilliant dude. And then we went down to Brown University to film with Suzanne de la Monte, who coined type 3 diabetes. She's one of the people credited as having coined that term. And that was a really awesome interview for me, because that's one of the headlines that I saw that most inspired me. This idea that our most feared disease could be a form of diabetes of the brain. Because, I mean, how empowering is that, right? Like, we know why people become diabetic if we're talking about, diabetes type 2. And, that these sorts of neurodegenerative problems could be metabolic in origin, to me was very eye-opening, My mother, New York Jew, grew up eating bagels and thinking that was, like totally healthy and avoiding fat. And when she gave me my first omelet as a kid, she was like, you can only eat these like, once a week because they're, they'll clog your arteries. And so the idea that somebody who tried to be health conscious her whole life was led astray, by the powers that be, to me was just eye-opening in many ways.
So what are your sort of hopes for this project at the end of it? I mean, it seems like if we have to work with 30-year-olds who have no symptoms, we've got to try and create media that's going to capture that attention.
100%. And I think that's why, look, I'm completely humbled to be in the room speaking at an event with some of the most brilliant people I've ever encountered. But I think that part of the way that we can sort of get this message to younger people is by surprising them. And I think that's why I've gotten some of the traction that I've gotten so far without the film even, I mean, it's not even public. You can't even Google the film. Because it's a little
world exclusive right here at the Functional Forum.
Yeah, it's a little surprising that a guy with 0 symptoms could be so into this topic and so knowledgeable. And I think that I speak for, I hope that I'm able to speak for millennials who wouldn't let something like that happen. You know, we're wonder junkies. We want to know as much about our health as we possibly can. You know, we're here in real time witnessing the cusp of the quantified self revolution. You know, the more we can know about ourselves, the more we can measure, the more we can manage and improve. And so I think that that's just something that like my generation like intuitively gets. And so if I can sort of help spread that message to somebody who might not pay attention if the message is coming from a guy in a lab coat, and if I can affect one person doing that, then I feel like I've done my job. And I've been particularly inspired by, you know, guys like Dr. Richard Isaacson, Dr. David Prohl, you know, guys who are really ushering in this idea of Alzheimer's prevention. Because what I've found is that, you know, by the time, and this is what I've learned in my research, by the time somebody actually presents to a neurologist, if you accept the idea that changes in the brain begin 30 years before the first symptom, then it's too late already, possibly. So you know, I'm obsessed with brain health. I want my brain to be functioning optimally, and so that's what I'm trying to disseminate.
You were a healthy dude before, but now you've been seeing Dr. Isaacson. Yeah. Tell everyone about your regimen that they could be getting all their patients on.
Well, I definitely eat a low carbohydrate diet. So, you know, if you accept the idea that Alzheimer's is a form of diabetes of the brain, you know, and that's an idea, then you want to eat as low carbohydrate, I think, as you can. There was a study that came across my Twitter feed yesterday saying that the best way to treat and manage type 2 diabetes is with a low carbohydrate diet. I feel like I'm functioning best when my insulin levels are not, you know, roller coastering, and I also eat a lot of sort of brain healthy fats like walnuts and omega-3s, DHA, stuff like that. I like coconut oil, you know, I like coconut stuff in general. Yeah. And Dr. Isaacson turned me on to cocoa powder and turmeric. And what was very interesting was that and this is sort of something that I'm learning as I sort of go down the rabbit hole, so again, I eat a very paleo-friendly diet. And I was kind of shocked to see that my LDL particle size was not optimal. It wasn't bad, but it was less optimal than I would assume for a guy who watches every single thing that he eats. And so I think that there's a very large nutrigenomic component there to everybody. And so part of what I've learned that I also try to spread is this idea that, like, I fully buy that you can advocate a one-size-fits-many approach, but a one-size-fits-all approach is a little unrealistic because, you know, as we sort of go down the sort of epigenetics rabbit hole and we learn more about the interplay between our genome and the food that we eat in our environments, you know, we're going to see that some people don't react the same way to saturated fat. And I, you know, apparently is one of those people. So one of the things that I learned that was talked about in that Wall Street Journal article is that maybe I should lower my saturated fat intake.
Okay. Well, hopefully this is exciting. We'll have a new generation of millennials seeking out doctors doing this type of medicine in a couple of years. Ladies and gentlemen, please give it up for Max Lugavere. Thanks, Max, for being here.
Thank you, guys.
Okay. We got one more message here from our a new sponsor, and then we'll kick it on to the next thing. By the way, get ready to tweet some questions for the panelists. Here we go.
Our way of life is a precious gift, one to be celebrated at every opportunity. With friends. While pursuing our passions, during quality time spent with our loved ones. And yet, many of us need help to maintain the quality of life we so deserve. That's why we've developed Petrolify. Petrolify's highly refined, all-natural ingredients are proven to meet the high-energy demands of our modern lifestyles. A daily regimen of Petrolify enables you to more fully enjoy the precious gift of life. With Petrolify, you will feel as though you can move the heavens and earth to satisfy not just your basic needs, but your every want.
The secret behind Petrolify is a proprietary blend of hydrocarbons and organic compounds known as petroleum. Every single pill contains literally millions of years of stored solar energy. In fact, you could say we took sunlight and put it in a bottle.
Petrolify might not be for everyone. Consult your doctor before taking. Side effects may include oil spills, deforestation, depression, loss of identity, corporatization, aquifer depletion, delusions of grandeur, birth defects, habitat loss, George W. Bush, the 405 in Los Angeles, ice cap melting, loss of democracy, thermonuclear warfare, species extinction, fracking, Al Gore, melting glaciers, oil price shock, petrodollar imperialism, fuel-centered foreign policy, consumerism, automobile dependence, native culture loss, Wall Street tycoon, traffic jam, the Dukes of Hazzard, Frankenfood, military adventurism, and extreme cases, total and complete human extinction.
Petrolify. Don't just seize the day, seize life.
You like that? I thought that was relevant, especially with the climate march and all that a couple of weeks ago. So look here, we're live. The evolution will be televised, and it's happening right now. So I'm super excited to welcome my next guest into to speak today. Dr. Jay Lombard is the co-founder of Genomind. He is also the former assistant professor of neurology at New York Presbyterian Albert Einstein. He is the former chief neurologist at the Bronx Lebanon Hospital, and he was referred to us by a couple of our favorite doctors here at the Functional Forum, Dr. Morrison and Dr. Hoffman, who both said that he really has the goods. Now, I was going to give him that introduction earlier, but I was on a epic high-powered email chain that Dr. Brogan here started, and Jay actually participated in it, and he probably didn't know that I was on it, but I saw what he said, so I got a little look into the mind of this guy and who he really is. And I just want to read you what he wrote. He said, "Let me point out the obvious, though, in case we overlook it in efforts to improve the well-being of our patients. The macro issue is as important as the molecular ones. What is the macro issue, in my opinion? It's the realization that every neuropsych issue is fundamentally about disconnectivity. The principle is no less apt at receptor sites to the relationship to ourselves, our loved ones, and the universe." I just thought that was really beautifully said, and that is the character and the quality of person that we love to have here at the Functional Forum. So, here we go. This is Dr. Jay Lombard with the third wave of biological psychiatry.
Is there a pointer? Let's see. Thank you very much. It's a hard act to follow, that wonderful new drug made for us. Trying to get some samples from my rep. So we are at I think, a very critical point in healthcare, and I think that those of us who have the opportunity to treat patients with psychiatric problems know it's an incredible responsibility and also an incredible honor, because unlike other areas of medicine, psychiatric conditions impact us in the deepest way, really. People with depression or dementia or schizophrenia, autism, those other conditions, affects the entire experience of being human. So I think that this takes a great deal of understanding and responsibility to be involved in the care of patients like that. And I'm really honored to be here to speak to you tonight about what I titled the third wave of biological psychiatry. And why do we need this wave? Well, the first issue is that we know that mental disorders are highly ubiquitous, right? So I think that if I asked people in this room, how many of you had direct experiences with a psychiatric problem, either in your personal life or professional life, I think we'd all be hard-pressed to say that there's any person here who's escaped some direct experience with either depression or post-traumatic stress disorder, autism or ADHD. So these are really, really ubiquitous conditions. And I think that they are affecting just about everybody. And the question is why, right? Why is it so ubiquitous? And if you look at conventional psychiatry, how good a job are they doing in regards to treating patients with psychiatric problems? And this is called the STAR-D study. The STAR-D study looked at, these are tertiary care centers, so major teaching hospitals across the United States, very good at psychopharmacology, highly experienced, taking patients with severe depression, not just the worried well, people with very, very severe mental illness. And what is shown here is that there's a significant percentage of patients who remain refractory despite optimal types of care and therapy. And the question is, why is that the case? I mean, this is not, going to your local psychopharmacologist. This is, the cream of the crop in terms of using medications, and people exposed to 3, 4, 5 medications, and yet we still see a significant, substantial number of people who remain refractory. And this is depression. If we take post-traumatic stress disorder, we don't have any treatments for that condition. We just don't. If you look at autism, which is not one condition, by the way, it's many different conditions, we don't have good treatments for that. If we look at schizophrenia, we don't have good treatments for these conditions. So why? What is it we're missing here? And, there's obviously, this could be a very, very long discussion, but let's just talk about this idea of stress, because we all use this term, but what does it actually mean from a molecular type of pathway? What does stress do to us? Because stress is one of these things that doesn't cause any particular disease, but contributes to almost every single one of them. So I think we need to understand the role that stress plays in the biology of psychiatric conditions like depression. And I don't want your eyes to roll over this, because my goal is to actually show you that stress, the pathology of stress, really integrates lots of different systems in our biology, including the endocrine system, the adrenal glands, our heart rate, blood pressure, all these different parameters that play a role in this condition. And I really don't want your eyes to roll over, but to show you this, I think, a very important slide, and I'm going to try to make this very sexy so that maybe they'll do a cartoon about this someday. But why is this slide so important to me and for this lecture today? Because it explains something that's very, very important to understanding neuropsychiatry. And the question is, how does our phenomenology, how do our mental states affect our biology? How is it if we experience things like stress, depression, loss of attachment of our PowerPoint presentation? How do those really negative emotional experiential states affect our biology? And the second question is, how does our biology affect our phenomenology? How is it that things that go on at the molecular level affect our cognition and our emotional states? So I think it's worth kind of walking through this as a roadmap to understand where there are opportunities for us, both in non-pharmacological or other types of strategies, to actually reduce this pathological cascade. So here we have the state called stress and depression as sort of the ubiquitous state of being alive in the year 2014. I could say something again, sorry about that. I don't know why that happens, but we have this neurotransmitter called glutamate, which is an excitatory neurotransmitter. This sets into motion a cascade of really negative pathological processes in neurons in the brain, including a heightened influx of calcium into neurons, high cortisol. These effects affect both the nucleus and the mitochondria. So we hear a lot about mitochondrial dysfunction in psychiatry and neurology. One of the ways that happens is that these negative signals through glutamate actually converge on the mitochondria and change the permeability of mitochondria in such a way that you end up releasing pro-death factors, okay? Factors that basically communicate to the cell that life is no longer worth living. They're called caspases. And wow, again, I'll probably never be invited back here again if I keep doing that, sorry. So what does that actually mean? So it's not important to understand exactly all these steps, but just to show you there's a direct relationship between phenomenology and biology, where if a person's experiencing a state of life not worth living, that gets communicated to the biology. It gets communicated to the biology through these pathways in which pro-death factors, these apoptotic factors, communicate to the cell to go into apoptosis or cell death. Okay, now it's not all bad news, okay? So we have what are called pro-life messages as well. Those pro-life messages come from neurotrophic factors, things like BDNF, or brain-derived neurotrophic factor. These coordinate things like serotonin and other catecholamines to promote these factors that actually inhibit cell death and promote cell life. So you have this kind of yin-yang process going on between our biology and our phenomenology about whether life is worth living or not. Interestingly, if we look at BDNF, there are lots of things that we can do to increase BDNF that are non-pharmacological, right? Moving, physical exercise will promote BDNF. certain dietary supplements, including omega-3 fish oil and certain flavonoids, promote BDNF. So these actually have been looked at as novel antidepressants because of their role on promoting BDNF. Now, the second thing we can do is block this pathological, cell death pathway by either blocking glutamate, reducing cortisol, or reducing this high calcium. And I'll talk a little bit more about that in a couple of minutes as well. So, and now this thing doesn't go forward well. Okay, so what happens under stress is that the hippocampus, which is our memory center, is the most vulnerable. That's why there's a high risk of developing Alzheimer's. Depression is one of the major risk factors for developing Alzheimer's disease. You can develop, atrophy of these memory centers with prolonged stress, probably due to persistently elevated cortisol, which is a neurotoxin. High cortisol is a toxin to the brain. And if you look at these conditions, major depression, post-traumatic stress disorder, Alzheimer's disease, all kind of converge on this high cortisol promoting cell death. Okay, and this is a long slide that I'm probably going to skip in the interest of time, but to those of you that really love neuroscience, just to show you some of the key takeaway points here, which are basically due to the fact that stress has an effect on dendrites, which are the communication network of the brain, synapses, and neurogenesis. And those of you that really want to know much more about this kind of work, right here at Rockefeller, Bruce McEwen has done most of the most important work on the effects of stress, its damaging effects in the brain. So we need to take a top-down approach. Before we go into the molecular stuff, what's a top-down approach mean? Basic things: promoting physical activity, cognitive behavioral therapy, mindfulness, prayer, social support, integration. These are the kind of obvious things that we've kind of extracted away from psychiatry by having a model where it's a drug-only model. These are really basic, and the reason that they're not promoted is you can't sell them. I mean, that's unfortunately why they're not overly utilized in healthcare. Now, what about a bottom-up approach? So at Genomind, we've looked at key genes that are related to psychiatric symptoms despite what a particular diagnosis is. And I'm going to go through a couple of these with you because they're really, really quite interesting. So first of all, something called the serotonin transporter gene. How many of you actually have heard of that gene? So about half of you have. So this is interesting work that began with Dr. Caspi at Duke University that looked at the effects of the serotonin transporter and its role in stress reactivity and vulnerability for depression. What he discovered, and I'll show you some of the data on this, is that your risk of developing a major depressive episode or post-traumatic stress disorder or other psychiatric symptoms was directly related to the presence of short transporter alleles, meaning that something genetically about the serotonin transporter led to vulnerability. So just really quickly, a short means that the transporter is shorter, literally, the serotonin transporter, versus a long transporter. And this is one of these, size really does matters kinds of genes. But it's very clear linear axis relationship between vulnerability for depression and having the presence of these short transporters. Why is this significant, this particular study? Because it tells us two things. It's not strictly biology, and it's not strictly nurture. It's really a nature and nurture story where you have to have both sort of a perfect storm of genetic, biological vulnerability with, the experience. Because you can have the worst genes in the world. If you don't have exposure to negative situations or negative life trauma, you're not going to get these types of conditions. You need this, what's called epistasis between genes and environment. Another gene that was really, made the New York Times, which is, the gold standard of medical literature. This was a paper that came out, and this, to me, when I go around speaking in the country to psychiatrists, this is such an important piece of data. And yet people look at me like, what are you talking about? So I have to try to explain this. So calcium genes are basically ion channels in the brain. And I tell psychiatrists they need to think of themselves as cardiologists of the brain. Because just like in the heart, we have ion channels that relate to the excitation of the brain or the relaxation of the brain. The same thing in the heart, the same thing is true in the brain. So that excitation is related to the traveling of these calcium channels, all right? Now, why is that big news? Because in many different studies, these calcium channel genes have been displayed to be abnormal, regardless of what the psychiatric condition was. Schizophrenia, bipolar, autism, major depression, ADD are very different clinically, and yet the presence of these calcium channel genes is significantly more likely to have a variant in them with those conditions. What does that tell us? It tells us that fundamentally psychiatric and neurological diseases are diseases of imbalance between excitation and inhibition, sort of a yin-yang idea of going towards something or retracting. These ion channels regulate the oscillation of the brain. And when you have these variants, no matter what your condition is, this gives us a much more specific target to treat these patients rather than symptomatically. Okay, and now it doesn't want to move at all. So anyway, one of the neurotransmitters you've probably heard about is called glutamate, which is related to these calcium channels. And guess what? We see patients that with seizures have a higher rate of ion channel genetic variants, migraine, neuropathic pain in the psychiatric area, bipolar, post-traumatic stress disorder, autism, and TRD. So we can move away from a categorical diagnosis. We say, you're autistic. No, you're not autistic. You're bipolar. No, you're not bipolar. Maybe you're schizoaffective. I mean, this is what goes on in terms of psychiatric diagnosis. The discovery of these channels moves us away from a categorical nomenclature to a dimensional analysis where we're talking about what's the underlying biology of these conditions. I mean, that is really exciting, at least to me. Okay, so what happens? What is the problem here with calcium ions? What's the big deal? Well, what happens is that there's a neurotransmitter called glutamate, which is like the Jimi Hendrix of neurotransmitters, okay? Glutamate amplifies stuff. It activates stuff. So it's involved in memory. It's involved in cognition. But too much glutamate leads to cell death. And we know that a lot of neurological and psychiatric disorders are associated with this hyperglutaminergic state. So it's worth going through this process. We release glutamate. It binds to receptors. It opens up those ion channels, right? This is what we talked about, these genes that allow these ion channels to get into the neuron, activating these lipases, proteases, endonucleases. These guys are like detergent for the cellular structures, and you have cell death. So here's the cascade. Right? We have glutamate, excitotoxicity. It gets into those neurons through these ion channels. We have cell death. Now we can begin thinking about a much more rational approach to neurodegenerative diseases like Alzheimer's, to conditions like Parkinson's disease, where there's been data that by regulating these calcium channels, we can actually be neuroprotective in certain degrees. We're really kind of honing in on what is the enemy in the brain at a molecular level, right? Still have to go to the macro level after I can turn this thing over again. Okay, so what do we do about it, right? So I don't want to be a doom and gloom guy. I hear that from my wife enough, so I don't want to, belabor the doom and gloom. She tells me not to watch the news anymore. But okay, so what can we do non-pharmacologically that can actually reduce glutamate and be neuroprotective and help as antidepressants and other effects? And these are all pretty strongly evidence-based nutrients. The one I would tell you that is most strongly evidence-based is something called N-acetylcysteine, and it is a very inexpensive supplement. There are hundreds of clinical trials in terms of its relationship of being efficacious in things like addiction, autism, schizophrenia, and depression. Okay? So what does N-acetylcysteine do? It's a novel glutamate antagonist. It reduces this Jimi Hendrix excitotoxic neurotransmitter. It does it by actually regulating the exchange of glutamate for something called cysteine, which is an antioxidant. And again, there's several beneficial studies that you can feel free to Google today on its beneficial effects in a number of neurological and psychiatric conditions. Besides N-acetylcysteine, we have the inability to do this again. Okay. Okay, so this slide's a little bit out of order, but here is our way of actually regulating these abnormal calcium channels where we want to prevent this from getting into the neurons. There are lots of pharmacological and non-pharmacological ways of dampening glutamate neurotransmission and preventing this excitotoxicity. So omega-3 fish oil, one of the ways that it's actually cardioprotective as well as neuroprotective is by preventing this excess of calcium from entering into neurons. Okay? Magnesium is another example of a compound that actually occupies this channel like a bouncer at a nightclub, preventing excessive calcium from depolarizing the neuron. So magnesium, very inexpensive, very good agent to reduce this excitability. And this is just a graphic of that. Here's the glutamate NMDA receptor. Magnesium occupies this channel, preventing the excess sodium or calcium into the neuron, preventing this excessive depolarization. Taurine is, unfortunately for the Red Bull makers, is really not a greatly positioned amino acid, but although it does help mitochondria. But taurine is a compound that actually reduces excitability as well. And it does it in a very similar way by preventing this excessive calcium influx in neurons. And here's something we hear a lot about, and this is actually quite a long discussion about this idea of inflammatory processes. And many of you have probably seen Brain on Fire. It was a book that was written about a woman that had something called NMDA encephalitis. Rare condition. People should not go out and ask their doctors if they have it. It's not very common. But NMDA is the glutamate receptor, and this particular patient had antibodies to glutamate that led to her psychotic condition. We now know that many neurological and psychiatric conditions are associated with a hyperinflammatory state. If we go back to that first slide I showed you, where you have this abnormal cortisol and glutamate, the best way to think about this, in my mind, is that pro-inflammatory states and glutamate states are really parallel. So if you think about glutamate as being exciting the nervous system, the pro-inflammatory states are doing the same thing in the immune system. Okay? In fact, arachidonic acid, which is a pro-inflammatory molecule, actually blocks glutamate reuptake. So by having an inflammatory condition where you have high arachidonic acid, you are basically giving more glutamate to the brain, more neurotoxicity. And inflammatory relationship, really, you can't open up any journal right now and finding significant evidence of the inflammatory processes. 5 minutes left? Okay. So to cut to the chase here, you know, some of the things that we developed at Genomind are looking at ways of using genetic testing to help clinicians both use pharmacological and non-pharmacological. We are an integrative company. We don't believe that medications are inherently evil. It's just that we're not using them properly. So we're trying to really help to refine choices for doctors in choosing either medications or non-pharmacological agents based upon genotyping. If we take things like the serotonin transporter, what information, how useful is that to a psychiatrist or to a mental health provider? Well, it tells them that this patient has higher stress vulnerability, lower stress resilience, higher cortisol, okay? So things that actually reduce cortisol and reduce that fight or flight response could be very, very helpful for patients, okay? And just a quick study here. We took those STAR-D patients, the ones I showed you earlier, treatment-resistant patients, patients who failed 3 or more medications, whether it's SSRIs, Wellbutrin. These are very treatment-resistant patients. We gave the psychiatrists who are part of the study genotyping to allow them to actually get better treatment choices based upon looking at the biology of these conditions. And this was quite remarkable. What we discovered is that these patients who were refractory to everything actually started getting better, okay? Big, big numbers here. And the people that we've shown this data to, which are like psychiatrists at Mass General that have really, really put us to the you know, really have asked us, you know, why is this happening? Why is this happening? So we actually looked at specific things that actually make a huge difference that the doctors would not have otherwise had at their choice. And those are things like methylfolate, which is a non-pharmacological agent, increases catecholamines, helps with depression in certain patients. Things like N-acetylcysteine we talked about. So this is, in my mind, the third wave of psychiatry, which is taking both biological data and psychological data, integrating it in a way where we treat the whole patient. And I think I made the time. Thank you.
There will be lots of time for questions here. Thanks so much, Dr. Lombard. I appreciate your talk there. Yeah, take a quick seat, and then we'll come back for questions here. I just wanted to give a shout out because most of our doctors here are really looking at dealing with the core. You know, functional medicine has been described by many people, including Dr. Kelly Brogan when we were on on HuffPost Live as root cause resolution medicine. And so what do we do if the cause of the illness is in the home? And that's why we're really excited to have as one of our sponsors
You want a healthy lifestyle
these guys.
for your family. You want a healthy lifestyle for your family. That means good nutrition, exercise, mental well-being, and preventative health care. But it also means a healthy indoor environment. After all, that's where you and your family spend most of your time. That's why you need healthy habitats. Right now, your home almost certainly harbors environmental toxins, VOCs, carcinogens, allergens, surface and waterborne bacteria, mold and mildew, perhaps even harmful radiation. All of which alone or in combination can cause chronic fatigue, sleep disorders, allergies, asthma and other respiratory ailments, headaches, dizziness, and even has been linked to autism and ADHD. At Healthy Habitats, we're certified market leaders in indoor environmental wellness, committed to addressing your entire home's air, water, surface quality, and so much more. It begins with a phone call, then a comprehensive low-cost home visit and inspection. We'll remediate any deficiencies using only the safest, most technologically advanced and cost-effective solutions. And Healthy Habitat members receive routine scheduled visits to ensure a lifetime of healthy living for you and your family. With our help, you'll achieve true indoor environmental wellness. And that means good health and a great peace of mind for you and your family. Call Healthy Habitats today and bring healthy home.
Look, I know this is a non-traditional sponsor for a medical event. If you go to the functional medicine events, you see hundreds of supplement companies and labs. But I think this really gets to the cause of a lot of chronic health conditions, particularly in the Northeast. They've got some really great stuff working with mold. There's a ton of rain, a ton of mold. And maybe that'll be a good question for the panel. So we wanted to have an extended panel for tonight's event because I know there's a lot of people interested. We got psychiatrists in the room. We got people tweeting in all kinds of questions. So we've got a dynamite panel for the event this evening. So the first person, I'd love to give you each a round of applause here as they come up. Dr. Richard Isaacson is at the forefront of preventative neurology and preventative Alzheimer's prevention, and we're so glad that you could be here, Dr. Isaacson. So Dr. Isaacson, can you join us here? The next guest is Mr. Kale himself, New York, Columbia University Assistant Professor of Psychiatry and author of 50 Shades of Kale, Dr. Drew Ramsey. I also was really excited to have the opportunity to bring in Dr. Shetreat-Klein. She is a pediatric neurologist. She is working at the forefront of brain mending. It's the name of her clinic. And we're really excited to have to give you a view on pediatric health concerns. Dr. Shetreat-Klein. And then I was going to sit on the end, but I think we should probably have Dr. Lombard up as well, and I'll sit in the audience. So you want to sit there? Dr. Lombard will be here for questions as well. All right, I'm going to come and sit here, and we'll have questions from the audience. I'll come around in a minute, but I'm just maybe going to start here. So first question for you, Drew. You know, when I was telling the, you just have to flick the mic on. Just flick it up, and you'll get the thing there. So
La Sonato.
when when I told our team at our medical advisory board that we were getting the smartest, sexiest psychiatrist in New York on the Functional Forum, they said, but you guys always have Kelly Brogan. She's spoken like 4 times. So I just said, well, we'll just use Drew. He's good. So Drew, quick question. Kale Day was last week. Awesome press. A lot of great things happening. Just for the people out there, I mean, you're a psychiatrist. Can Kale save us from psychiatric meltdown?
We've gotten to the point, James, only Kale can save us now. So Kale saved me, and I think it saved a lot of us in terms of I just really felt with all the controversies in health and mental health, I wanted something that we could all believe in, and that was Kale. And then as opposed to what we've done in medicine for a long time was telling people what not to eat and what to avoid, of just something that we can all agree on, this is healthy to eat, and to learn the lessons of that food. So I do believe that Kale can save us, as it helps us eat in a way that supports our microbiome, supports our overall health, is anti-inflammatory, and also supports the health of the planet, right? You can grow kale anywhere. Everybody can afford kale. And so I just thought it was a nice set of lessons, and it's been really wonderful watching people get excited about kale.
So out of the 300,000 kids that got a free kale salad last Wednesday, how many of it was eaten? How many of it was thrown at another classmate? And how much of it was tossed out? Do you have any numbers on that?
So I got to sit at PS 87 with Bill Telepan, a Michelin-starred chef, and watch him serve kale to 900 kids. And then I got to sit at a table with these kids. And a lot of people had this experience on National Kale Day. We think kids won't eat healthy food, and that's just not true. When you sit down, and it was amazing. We started with the kale chips, and they said, "Oh, this is great. Where's this come from?" So it was like a big pile of kale. I said, "Oh, it comes from here." They said, "Oh, can we eat that too?" I said, "Yeah, eat the raw kale." Sure. So they ate the raw kale. That's pretty good. Where do these kale plants come from? And they had baby kale plants. So we brought over the tray of baby kale plants, little sprouts. They said, "Can we eat those too?" And little hands started just digging at the little baby kale plants. And so
it's a gateway drug.
It's a
gateway plant.
So so a lot of kids ate kale, and I think I love the I think it's the farms to school philosophy. Don't yuck my yum, right? Not everybody loves kale. You don't have to love kale to eat healthy, but let's get kids trying more fun, nutrient dense foods like kale and seeing if we can make an impression.
I think that's such a great thing, and Dr. Ramsey is a great example of someone just taking initiative to do something amazing, and in 2 years it's just had such a great effect. And we've got a master plan to take it even bigger next year. So watch this space. Dr. Isaacson, I'd love to just ask you, for those of you who are unfamiliar with your work, what is it that gets you so passionate about basically doing Alzheimer's prevention to 30-year-olds with no symptoms?
So, I mean, Alzheimer's is disease in the brain. I've always been fascinated by the brain since I was probably this big. But actually, I have a family history of Alzheimer's disease. I have 4 family members. My great-uncle Bob was diagnosed when I was in high school. I actually diagnosed my dad's cousin at a wedding several years ago. So I've actually seen kind of the evolution of our understanding of Alzheimer's disease when I was this big, and now I'm a little bit like that. And the disease starts, as Max said, 20 to 30 years before we diagnose it. It's just like heart disease and diabetes. It's the same thing, but neurologists, primary care docs, we just haven't been taught to think that way. So 30-year-olds and no symptoms, that's when we need to think about Alzheimer's prevention.
That's amazing. I mean, I have a family history too, and I'm excited. So, what are some of the ways that you are engaging change? And are other neurologists and people interested in this?
Baby steps. We're making progress. I started the Alzheimer's Prevention Clinic at a New York Presbyterian Weill Cornell Medical Center in New York City a year ago, July 2013. I've actually been seeing Alzheimer's prevention patients, family members of Alzheimer's patients, for about the last 5 years. And went over to University of Alabama in Birmingham in March, and they just started a couple months ago. We have the folks from Brazil coming for a site visit in December. And then actually we're having a New York Academy of Sciences is actually sponsoring a nutrition and brain health and dementia prevention conference. This has not exactly happened before. People from Oxford and Norway and National Institutes of Health. I mean, it's all kind of converging. So baby steps, that's number one. Number two, there's so much we can do to take control of our brain health. There's no one magic pill. There's no way to prevent Alzheimer's or cure Alzheimer's yet. But based on really spectacular data, 1 out of 3 cases of Alzheimer's is preventable, period. Okay. When I used to say Alzheimer's and prevention in the same sentence, they would throw tomatoes at me. That was 7 years ago. And a couple of years ago, they'd look at me like this, and now it's okay. So there's no one-size-fits-all approach. Again, like Max said, I take a pretty comprehensive approach. Nutritional, obviously, is key. Exercise, lifestyle changes, environmental factors. Exciting things like musical experience, lifelong musical experience. I had to join a rock band. Very specific vitamin. Actually, I did. I have blisters from playing last Sunday, but I mean, anything and everything as long as it's safe and grounded in scientific evidence. And it really depends on genetics too. That's what we're learning.
So, I mean, just one more question. I mean, you've been practicing ahead of the science for a little bit, and now you're doing it. So, what should we be practicing now so that we're doing the science from 5 years' time?
Right. So basically, in the United States, it takes 15 years for something that's proven in science to be translated into clinical medicine. Drives me crazy. So I read something, and as long as it's grounded and safe, I implement it. What can we do? Get educated and get informed. We're working on things. We're trying to educate people online. We have Alzheimer's courses, Alzheimer's prevention courses, all free, all online, evidence-based, reviewed by specialists. I think that getting educated and getting informed is absolutely essential. Getting out there. Can I talk about a thing that we're working on? A project?
Yeah.
Okay, yeah. So it's
Go
called
nuts.
Alzheimer's Universe. alzu.org, alzu.org. It's not like a promo, but it's completely free. It's completely nonprofit. It's completely Cornell, Columbia. All sorts of places all around the country and around the world. You can learn about what what everyone can do online from the comfort of your iPad, iPhone, whatever.
That's great. Dr. Shetreat-Klein, let me introduce you here. I've been a big fan of your work for a long time, really care about the autism community and particularly environmental pediatrics. Your work is all on brain mending. First of all, before we get into mending the brain, what do you see as sort of the major factors that are driving brains that need to be mended?
Well, I think, I originally got involved in this work because I started to see so many children when I went into practice who were really ill and were medicated, coming to me on 3, 4, 5 different neuropsychiatric medications, which was pretty mind-boggling, and 5-year-olds, 7-year-olds, 13-year-olds, and no one saw any reason to really change that. So, and a lot of parents, it seemed like, also felt their kids were sitting ducks and they were waiting for what was going to happen to their kids. So I started to look at food as the first evidence-based treatment, and it was really unbelievable, actually very startling, because I didn't have a lot of experience with that when I first began to practice. But changing diet was so transformative in kids because they are very resilient, usually, and their brains are very plastic. So the kinds of building blocks were healthy fats. I mean, things we've talked about here, kale and all the cruciferous vegetables that are, full of sulforaphanes, activating NRF2, turning on brain-derived neurotrophic factor, and gut flora, so fermented foods, probiotics, and kefir and things like that, which are really powerful because everything in the brain begins in the gut, and I think that the gut is soil for the brain to grow. So if you have an unhealthy gut and you're not absorbing your nutrients and you're not being nourished well, it doesn't matter what you're eating. So gut health, vegetables, and actually I encourage kids also. I don't think that a lot of young kids do terrifically well on a very strict paleo diet, actually. But I definitely work with whole grains and, in sort of smaller amounts, I think, than average. Definitely avoiding processed carbohydrates and sugar.
What's medicine going to look like when the current crop of autistic kids are now adults?
Well, I mean, I think it's not just the kids with autism, although, we're looking at increases that are pretty astronomical at this point. So we're looking at kids who are, right now around 1 out of 50. In another 7 years, we're looking at, 1 in 2 if it continues at this rate. So pretty terrifying.
By 2030, I heard that those rates will be up there, 1 and 2.
It's going up, but we're also looking at a lot of other chronically ill kids with a lot of different conditions. And so, I mean, I think we need to be looking at, some of the stuff that we saw in some of those great kind of cartoon videos about environmental health, looking at how we're growing food, looking at what we're doing in our environment. And I think that actually, although a lot of people find that really hopeless or, feel pessimistic about it, I think we just all have to start raising our voices, especially as practitioners, because we have that kind of, we have the credentials and we have some authenticity in what we're talking about, and we can bring together science and what's happening in clinical medicine. And, from my point of view, what I worry about is that even in the integrative medicine community, but certainly in the mainstream medicine community, children are really neglected. They're not sexy. No one really wants to talk about what's going on. And what my colleagues and I are noticing is that kids are getting less resilient, even as we're treating them. And I'm using a lot of food, I'm using botanicals, and I've seen really amazing results with kids, and yet they're getting sicker, and we need to start paying attention to that.
It's amazing work. Well, we're going to take a lot of questions here. I actually have one from Twitter that I want to ask you, and I'm going to ask this to Dr. Lombard, but I think you're going to be a little bit biased, so I'll have to ask all of you. Will Cole, who's a favorite functional medicine doctor from Pennsylvania, he asks, what are your top favorite labs to look at risk factors for brain health problems? I'll start with you, Jay, but we're not going to finish with you because we know you're biased.
Well, I should recuse myself from the answer to the question, except to make a point that when we look at biomarkers in mental health and brain health, it's not only genetics. Other biomarkers are as important. Something called proteomics, which is really very specific for inflammatory markers for these conditions, like Alzheimer's disease, is increasingly important. Epigenetics will be a very important biomarker for psychiatry. What is the effect of how the environment affects gene expression? And brain imaging will be extraordinarily important for early diagnosis of things like Alzheimer's disease. So I think it's not a commercial endorsement for a lab. I think it's understanding that we need to have an integrative approach of many different types of biomarkers to help prevent conditions in a prodromal stage. So autism, we have a much better success rate to identify those patients earlier on. And if I could just give a call out to Armin Aladini, who's a celiac specialist at Columbia that's done work looking at non-celiac proteins associated with autism and schizophrenia. And this is very important because these are very highly elevated in prodromal states. So the ability to actually go on a gluten-free diet before a person develops a florid psychotic episode is very important to commercially get those kinds of diagnostic tests out there for that condition. And of course, I like Genomind.
Doctor, what are you doing for kids with lab testing here?
Well, if we're talking about predicting brain function and disease, I definitely feel I live in the world of epigenetics. So I see a lot of kids that come to me with various different genetic disorders. I think, pediatric neurology is where we see a lot of that. And so my interest is, yes, in knowing what the genetics are. And I like to look at things like MTHFR and other methylation markers. I do look at some of the, some other genetic kind of detoxification polymorphisms and things like that sometimes. But I also feel like, for me, I'm thinking of the body as a basin, and I'm thinking of how can we lessen what's in the basin and how can we open the drain. And I actually find that environmental factors are so powerful in that way, botanicals and food and a lot of other things like, talking about music, talking about nature. I mean, there's actually great data for this. And so I think it's dangerous to get too caught up in the genetics, even though I think it's important to know that. But I think there are some good labs, and I haven't yet talked to Jay about Genomind, but I will be.
Well, let's take some questions from the room. I missed my cue earlier, so we are going to get a brief moment of Cypress Hill. So I hope you'll excuse that. But I'm going to pass the tickets on here. Sorry. Okay, Dana, here we go. I know this is one of your favorites. So here we are, Dana Cohen. Welcome. Let's have a question for the panel.
Okay. So nobody's mentioned can you and do you measure neurotransmitters in New York? And is it worthwhile doing?
Well, it's a loaded question. So certain urinary neurotransmitters are probably correlating with systemic alterations. So, for instance, norepinephrine is probably a useful urinary neurotransmitter to check, but the other ones probably are not. So measuring, urinary serotonin is probably a complete waste, since there's no direct correlation between what's in the urine and what's actually going on in the CNS. And these receptors are so complex. It's not a matter of having a high or low level of a neurotransmitter. It's much more granular than just measuring a neurotransmitter and then ordering a supplement that the same company that is actually testing is actually recommending. So it's a little bit of a firewall that should take place in my mind. So glutamate is, again, it's one of these things that the pharmacology of glutamate is very complex. There are different glutamate receptors. And I think that the key thing is to know if a patient's in an excitatory state, because a lot of these conditions are excitatory. The ion channel genes predict a higher vulnerability for an excitatory state. So it's a useful surrogate marker for things like what we call bipolar, even though it's not a diagnostic test for bipolar. We know bipolar is associated with high glutamate. But measuring glutamate in the urine, I'm not exactly sure if I would do that, to be honest with you. I mean, I don't know what the other panelists feel.
I don't measure neurotransmitters on anyone because usually you can have a good sense of what's going wrong by sitting with the patient and listening. And there's not good evidence that they're going to help us in a treatment decision in any way. At least that's been my clinical experience. So I think it's where one of the mistakes we make is that testing, like Jay's assay, is really great for complicated patients. But when you have somebody in your office and they're struggling in some way with the depression, that's not, I don't need a lot of lab tests to diagnose that. You know, I want to check a B12 level and a TSH and then give really good basic clinical care. Where these factors are really helpful, and I think where we're really dropping the ball, is things like for example, I've got a 10-month-old son. We have a little gluten intolerance in our family. No clinician ever said, you know, let's make sure and really be clear on the B12 levels in everybody. And let's see, does your kid have a celiac issue? Now, I'd want to know that right now, right? Because right now is where we would intervene, but that's never even been really suggested. So I think that's where we need to do a much better job with the tools that we have, implementing them, and where there's, I think, been a little bit of an over-enthusiasm of some tests that really don't have evidence that they help. And I like the L-methylfolate. That's a cool emerging story.
You want to add to that?
I know there's some people who swear by that test. I feel really reluctant to rely too much upon it. And I would just say there's a lot of tests out there. And I usually am prioritizing the tests that I do. I don't feel like I want to spend thousands and thousands of dollars of my patients' money. So I'm usually really limiting myself. And that is just not one of my top tests.
All right, we'll come back to you, Kale. Let's have a question here. Dr. Nazareth.
Yes, I have a couple of questions for the panel. One is is this autism, is it genetics with environmental factors? Because most of the medical literature is mainly pushing towards genetics. And I don't see autistic patients growing up and marrying each other. Most of those ones that marry each other and have autism are usually in Silicon Valley somewhere. So the other question with the kale, can you have too much of kale? I mean, it's you said 40 shades of kale.
50 shades of kale. Just,
even more.
Kale erotica.
But
it's a whole new
does
genre.
have an effect. It does have an effect on the thyroid, just like the other cruciferous vegetables. Wouldn't it be better to have kale with chocolate, maybe? That would have even a more beneficial effect.
You want to do kale first? All right. So current evidence says...
No, one question for Jay Lombard now.
So I think that the genetics of autism is very important, and we should not underemphasize it. The struggle that the basic scientists have with genetic testing in autism is twofold. One, we should not call autism a single disorder. It is not one disorder. There are many, many subtypes of autism, at least dozens probably. And the genetics that we know about this reflects those sub-endophenotypes. The issue is, and I think this goes back to the question earlier about diagnostic testing, don't order a test if you don't know what to do with the information that you get. So we're still struggling with, if we get genetic data for these autism subtypes, what are the meaningful interventions that we could take that will affect the arc of the disease as opposed to not having that data? And we're close to that point, but I don't think we're fully there yet. There's some examples of genetic testing that I think would be very helpful for autism. I think celiac testing, I agree with everyone on this panel, is a key issue here for a lot of neuropsychiatric problems. There's some genetics related to carnitine and carnitine defects in certain autistic children with language delay. But I think we have to be, the translational, it's like what Rich is talking about. We got to really kind of take some baby steps there to really wed the genetic data with asking the question, how will that information change our management?
Then why are the numbers going up so drastically?
I'm just going to, I want to comment on that because we have spent, decades now really focusing on genetics. But when you see the numbers going up like this, and it's been looked at, is it better diagnosis and all of that, it can't explain this kind of increase. You can't have a genetic epidemic. So there has to be a combination of genetic vulnerability and environmental factors that are working together. And that's why I think in all this time there's been this obsession with genetics, partly because I think no one wants to talk about environment. But I mean, they are several really good identical twin studies that pretty much rule out that this is primarily a genetic disorder. So we need to be thinking, I think, about a whole picture type of issue and not focusing only on the genetics. I mean, yes, it's true that there are some kids who are very vulnerable, maybe more vulnerable, but it's definitely, I think, more environmental.
The last question for Jay Lombard is, I know Genomind, I think I'm going to use that, your lab, because it looks like it's very, very important to do those tests. But more important also is to look at other factors in psychiatry, the gut-brain combination, the nutritional problems, methylation problems. And have you ever combined that with SPECT scans that Eamon talks about so much?
Well, stay tuned, because we are, going into the next generation, next reiteration of our diagnostic panel, which will be much more inclusive for integrative doctors. Our first panel is really primarily for conventional psychiatry, looking at genetics related to pharmacokinetics, drug metabolism. SPECT scan, I'll be honest with you, I think is not a great clinical tool. It lacks diagnostic specificity. It's very sensitive for what it's measuring, but to use that test to diagnose things like ADHD is really a wasted resource. And I'm sure I'd like to hear what Drew feels about thinks about that, because you're seeing patients on a day-to-day basis. But really, diagnostic testing, whatever that diagnostic testing is for patients who are complicated. It's not the straightforward patient with major depression or a condition. Don't do testing just for the sake of doing testing. It's really useful when we suspect that there may be an underlying dementia, for instance. When is a SPECT or brain imaging, if a patient has early depression or other psychiatric symptoms, that's the prodrome of Alzheimer's disease. We know it's a very common early presentation of Alzheimer's is to have psychiatric problems first. That's where imaging becomes very valuable.
Drew, you want to jump in? I know you're itching to talk about kale and thyroid.
I'm gonna get I do a lot more than prescribe kale. I just want to say it's like my whole shtick is like, hey, about your mom and about the kale. So first of all, there's no evidence that kale can cause hypothyroidism. That's a theoretical risk, because kale can interfere with thyroid absorption. So theoretically, if someone ate a very, very low iodine diet and ate a lot of kale, probably not even eating kale, you'd have to juice like a bushel of kale every single day, then potentially you could get into problem. There's been one case report at NYU of a woman eating 3 kilograms of bok choy every day, and she had a lot of medical problems. She was 82. So kale, it's been frustrating, I would say, because there's been a kind of kale backlash, and that's been frustrating in the sense that, so we're finally talking about something besides donuts, and we're talking about a healthy food, and people are excited about it. And I bump into people all the time who say, oh, well, but kale's really bad for my thyroid. Or a woman who said, you don't really absorb any nutrients from kale, right? And this is one of the healthiest foods on the planet. So again, it's a theoretical risk that I think got headlines. There was even a headline, "Can kale kill you?" And I think it's really trying to, so it took a little wind out of our sails. But the bottom line is right now, no, there have been no reports, and it's where we need better trials in the sense no one's ever done a kale trial, but a lot of women in their 40s and 50s get hypothyroidism, right? A lot of women in their 40s and 50s now eat more kale. And so that's a correlation that really doesn't prove any causation. Yeah, and also we have a very low iodine diet, and how do you overcome this? I like to eat my kale with seafood, and then you just don't have to ever worry about it.
That's good.
And chocolate. And in terms of scanning, I don't use any scans diagnostically unless in very, very complicated cases. I agree with Jay. That's something that it's an exciting thing to show patients a picture of their brain, but currently there is it's at times I think very misleading. I've seen a lot of patients who've had scans, and it's really led to a tremendous amount of misinformation and anxiety and concern that, again, good clinical care sort of took care of what a scan could not. Yeah, kale, little mussels, little glass of wine. I think will that prevent my Alzheimer's?
Come to my office. We'll talk. Yeah. One quick thing about chocolate. So oftentimes you'll look at a chocolate bar. I know that most of us in the room understand this, but there's sugar and butter, and more sugar and butter, and then there's a little bit of chocolate at the end on the last ingredient. Dark cocoa powder, for specifically if I'm talking about Alzheimer's disease, the pure cocoa flavonoids can improve blood pressure control, that's a bonus. Memory function, oh yeah, and insulin resistance. So cocoa flavonoids plus Mike. I'm going to dip Mike since I like this.
Chocolate covered kale chip for you, maybe?
I'm ready. I'm ready.
Dark chocolate covered.
No charge for the visit. Yeah.
Kels?
Don't know. Yeah, sounds good though.
Yeah, for Dr. J. Lombard. Yeah, the chart you had at the beginning involving the glutamate and the calcium and the tendency towards apoptosis, and then the mitigating factors that could push it in the other direction. I was wondering what the role of lithium was on that chart. Could you clarify that?
Absolutely. So lithium is a neuroprotective compound. In fact, there's data that in low lithium geographical areas is higher rates of depression and suicidality. So lithium should be considered an essential nutrient. But lithium actually blocks glutamate in a number of different ways. One is it affects something in the endoplasmic reticulum called IP3, which is a signal cascade that releases calcium into the cell. So one of the effects that lithium has to reduce glutamate is downstream by preventing this excess amount of calcium release. So lithium is a very, very important agent and probably one of the best, augmentation strategies for depression that psychiatry has ever discovered.
I got to say it into the mic so everyone streaming can hear. Do you have an idea what the ideal maximum dose could be?
So I actually would, again, defer to Drew because he's in
we don't
clinical practice.
generally dose anybody with lithium, but you can get lots of lithium in traditional mineral waters. And it's one of these things. Lithium has a bad name, right? It's one of these drugs. Everyone has a lithium level. Everyone in this room, everyone listening, you've got a little bit of lithium in you. And we used to eat and drink a lot more of our minerals in these traditional mineral waters. If you actually look, so 7-Up used to be called like lithiated like 7 citrus soda or something. So we have these, anytime you go to some place with an old hot springs, they advertise their lithiated water. And that's how we discovered lithium's effects, is it was mistakenly given as a salt. And the miners who got lithium, they were just kind of calmer and they liked being in the mine more. So, but generally we don't dose or give lithium as a supplement unless somebody has a depression or a bipolar disorder. Like 600 to 1,500 is about where we dose lithium for the most part.
All questions come through the mic, otherwise no one can hear it at home. So, Dr. Teach.
Jay, I was listening to you, and I listened to the idea that we're dealing with harmonics. So you're saying a little too much of this or a little of that. That fits in with this very much.
Yep.
The other thing is, I haven't heard anyone speaking of electromagnetic frequencies, which I think with the cell phones and everything are going to be vitally important from the environment. And also mold in the environment. I can reproduce symptoms on and off. I can reproduce depression. I can make them laugh and happy in the houses and in my office with putting it under the skin. I think that's really important. You can have the genetic problems, but if you take away the environmental problems, very often you can get them back to normal without even attacking the genetics themselves.
What are some of the big environmental issues there, Maya? Can I ask you that for kids, particularly with neurodegenerative diseases? What do you see as the bigger environmental insults?
I think that antibiotics, chronic antibiotics, and steroids are a really big deal because they're affecting the gut in really profound ways. I do think mold is a big issue, can be a big issue, but I do think also that you have to have an immune system that's already a little bit sick to respond as badly to mold as some people do.
Is that genetic or is that transgenerational epigenetic?
I think it's both. Let's see what else. Oh, and the EMF. Yeah, I mean, I actually think screen time. Yeah, well, and I think that kind of goes with EMFs too. I mean, I think there's both of that, and that's profound for children. I mean, it's incredible. And the data about EMFs is kind of growing now that, especially prenatal. is connected with neurodevelopmental issues.
I hate to say it, but yeast. I think it's very important, and we've seen some children totally turn around by treating the yeast.
Well, I think that that is true, but again, I mean, what we're taught, at least the way I'm looking at treating kids is rather than trying to kind of play whack-a-mole with like 40 different problems, is to try to strengthen them and get them more resilient. Because otherwise you're chasing after a lot of things, and in the meantime, while we're treating yeast, we're giving them antifungals, and then, you know, they have an overgrowth of something else, and then, I'm not saying that's always true, and I do think treating yeast can sometimes be pretty transformative. I think that, you know, gut flora in general need to be in balance, and there are microbes and other things, but I think that if you have a body out of balance, and you are not resilient, then that's when all those things start to really go wrong. But that's not the root issue. The root issue is underlying. So I think that that is for sure. All of these things are issues. I do think screen time is kind of a nightmare for a lot of these kids, though.
Can I ask you, Dr. Lombard, because we did an interview earlier just before this, and you started by talking about disconnection as sort of like the grounding factor in these neuropsych issues. Can you just speak a little bit about some of your thoughts with regard to connectivity and technological connectivity as regards neurodevelopmental or neurological disease?
Sure. I mean, it's a scary issue because obviously, you know, children are sort of the canary in the coal mine, right? And we're sort of looking at these increased risks of autism, which that number is astronomically frightening. And the issue is, I think we all need to accept that this is a multifactorial disorder. No one, I think, in this room, whether it's Alzheimer's or autism, would say that it's strictly genetics or strictly environment. It's always an interaction of genes and environment that is producing increased vulnerability for almost all these conditions. But what we talked about earlier, which is not my theory, so I think it's Dr. Cohen from Cambridge that talked, I think it's Dr. Cohen, talked about the increased risk of autism correlating with our technological and digital revolution. That we as a society are becoming more digitalized in terms of how we think of things. I had the opportunity to sit in a webinar last week, and there was a graphic of an axon with ones and zeros. And it made me think that, wow, we really kind of taking such a reductionistic idea that consciousness is purely computational. And that's what most neuroscientists believe, that our consciousness is our brain's a computational biological computational organ. And that really frightens me, that concept, because if it's true, then what we're saying is that autism is really an evolutionary response to how we are thinking about ourselves. And that is something we should give us pause, meaning that this type of behavior, the automated type of behaviors where everything is, you know, black or white, there's no nuances to communication or socialization, may be the brain's reaction to the technological revolution that we're experiencing. And, you know, I hope that theory is not right.
Dr. Isaacson, have you got any thoughts on that? I mean, it's a bit outside the box for you, but I'd imagine you'd be into it.
I'm like, I gotta like hold on to my seat after that one. Yeah, I mean, oh boy, yeah. When it comes to all of these things, I stress over and over that it's just like you said. It took the words right out of my mouth. It's not binary. You're always in this tug of war. And you're playing tug of war with your genes, and if you got good shoes, well, that means you didn't do this bad thing. And if you worked out and you're eating your protein and doing whatever you need to do, then that you got that in your favor. It's really complicated.
Yeah,
that's all I can say.
Well, yeah, no, I certainly appreciate that, and that's, you know, one of the things about this functional medicine movement is training doctors to think in a systems biology way, try and think about different systems and how they work together. And so, you know, we're right on the forefront of that. We've got a couple more questions. Dr. Vaughan Bowman, he's a naturopath here from Connecticut, building a massive center to help out some people in Stamford, Connecticut. They need it.
Thank you, James. Two quick mineral-related questions, one for you and one for Dr. Lombard as well. First question regarding the lithium, because you said upward limit of 600 milligrams inorganic. What about an organic or elemental form of lithium, and do you find it?
I don't mean to make an upward limit. I think is based on level when you're dosing, and so I was just sort of throwing out that, you know, when I dose people with lithium, I start out 600, 900 and go up based on blood level. So.
And do you have any thoughts on an organic or an elemental form of lithium and how it might compare?
Not really. Kelly, you probably know. I'm a lithium carbonate man.
I would just say that, unfortunately, while it's a compelling idea based on the epidemiologic studies, mostly in Texas, right, to use lithium elementally, I think you would agree, right? There's not much data. In fact, no data. So for the most part, when clinicians use it, it's like in the 5 milligram to like 20, 30 milligram range, right? And I found just anecdotally that it can be helpful for sort of like lability, irritability, but it's not really a compelling evidence-based intervention.
It's coming around. The evidence for lithium in low doses, it's starting to hit a little tiny bit with Alzheimer's, but I have to hold my breath because there's a dearth of evidence. I mean, it's just not there yet, but 5, 10 years from now, we'll see.
Excellent. That was I was wondering if it's just a matter of research catching up and physicians using it without, right?
And it's one of the things that changed, right? Just like iodine changed, like
Correct.
our relationship with these fundamental, I mean, they call lithium a primordial element, right? Because it was formed when like the Big Bang happened. So I like the idea that that's part of us or should be part of us, but we've taken it out of everything.
Right. Second question, Dr. Lombard, the idea of magnesium playing the bouncer for a calcium channel, is that simply just because, okay, this is another competing cation? Also, is there a form that you would prefer in terms of absorption and assimilation for that very purpose?
So magnesium is what's called a non-allosteric inhibitor of NMDA receptors. So it's similar to a drug called memantine for Alzheimer's disease. It has similar pharmacology in terms of reducing glutamate-mediated calcium influx into neurons. Regarding magnesium absorption, I mean, that's something that probably you would know much better than I would, to be honest with you, whether it's magnesium glycinate. I've heard people talk about that having a higher absorption rate. And, you know, probably ask one of the clinicians would be better. So
we can't hear. We won't be able to hear it at home, unfortunately.
Magnesium for the brain. So there's a researcher from MIT that was doing work on something called magnesium threonate, right? And he was, you know, in animals at least, was showing that there's higher blood-brain barrier penetration through the threonate form of magnesium. But I'm not sure if that would justify the expense of just taking regular magnesium. Maya, what, you know?
Yeah, I mean, I think it really depends on the gut health of the person. I mean, glycinate is what I use when I feel like there's, well, first of all, I mean, you can start giving chelated magnesium or, you know, magnesium citrate or other things, and if the person has loose stool, then you know they're probably not absorbing it all that well, and then you might move to something like magnesium glycinate. But I mean, if we're going to be mindful of what kind of money people are spending on these supplements, you might start with something more basic. I sometimes will also use magnesium taurate, right, you know, if I'm looking to kind of do a really, like, you know, calm the neuroexcitatory response, and that can sometimes give you a lot of bang for your buck.
What's everybody's favorite food with magnesium?
Chocolate.
What's your favorite, Drew?
I like dark chocolate, pumpkin seeds I think are a good source, leafy greens.
Kale? All right. Hey, this has been an unbelievably good conversation, and I appreciate everyone in the room with the questions and the questions on Twitter. I have to say, if you're interested in like the role of the gut and the microbiome and inflammation, if you can get onto our YouTube channel, Dr. Kelly Brogan's got her talk from the from April is got the most YouTube video views of any of ours. So that's it's a great one to check that out if you're passionate about it. I really want to thank Max and the whole panel here. Can we have a round of applause for everyone here on the team? It's been a beautiful forum. Thank you so much to Neuhaus and all the sponsors for having us. I'm sure there's going to be a lot of questions, but we'll see you on November 5th, where we're going to outline our plan for world domination. So we'll see you then.